In problem 89, we have this bar, which is very light. We assume there is no mass on this bar. And we have a lumped mass, 4 kilogram at this end of it. And at the beginning, the bar is in horizontal direction. We start to apply a force, 60 Newton at this end of the bar, which is gonna make this bar to rotate. And the force is gonna be perpendicular to the bar all the time. And the question is, when the bar rotates 90 degree, become at this condition, what's going to be the velocity of the mass at this moment? The force is always perpendicular to the bar, and we are going to find the velocity in the vertical position. And at the beginning, there is no velocity. So, of course, we are going to use work energy equation for this problem, which is very simple to use. So let's call this position 1 and the vertical position 2. So T1 plus V1 plus U prime from 1 to 2 is equal to T2 plus V2. At the beginning, there is no velocity, so there is no kinetic energy. And if I put my reference line here, at the beginning, there is no potential energy as well. U prime from point 1 to point 2. We have a bunch of non-conservative forces here. We have 60 Newton, which is always perpendicular to the bar, and also we have some reaction forces at point O. The reaction forces don't move. They are always here. Because of that, they don't do any work. So the work of the reaction forces is 0. But the reaction force here, the external force is 60 Newton, is gonna do work. And there are some, different ways to calculate the work of this force. Probably the simple way to explain it is, if you look at this force, it is always tangential to the direction of the movement of the force, right? So because it is always in the tangential direction, the work of it is going to be the force times the length of the path which is traveling, which is going to be the length of this quarter of the circle. So the work is going to be 60 times the length of this arc is going to be pi divided by 2 times r. And r is 0.2. So that's going to be the total work of non-conservative forces. Is equal to T2. At the end, we are going to have some velocity. So T2 is going to be 1/2 of m times velocity in the second point squared plus potential energy. Because the mass is going to move up, the potential energy, we are going to have some gravitational potential energy, mgh, and h is going to be 0.3 meter. So I need to add plus mg times 0.3. We know what is m, and the only unknown here is velocity. So we can easily find the velocity here. V2 is going to be 1.881 meter per second.